So children, after that, in the previous class we discussed about the types of surds, right? So after that we need to discuss about that comparison of surds. So comparison means what? Which one is greater, which one is smaller. That is comparison, right? So here comparison of surds. So we have here two types of comparisons. So first one is, if the orders of the surds are same, then how to compare that surds? If the orders are different, then how to compare that surds? So first one is, if the orders are same. Orders are same, then how to compare that surds? Okay, for example here root 2 and root 3. So order means what we said here. If the surd is in the form of nth root of a, then n is called that order of the surd. So here n is equals to what? N is equals to nothing is there means, in previous class we discussed that nothing is there means we need to consider it as a square root. So here n is equals to 2. And come to this one. Here what is that? N. Here also n is equals to 2. So these two surds are having that same order, right? Then we can compare these two surds very easily based on their radicands. So here which one is known as radicand? Here 2 is radicand and here 3 is radicand. So if their orders are same, then how to compare that surds? That comparison based on their radicands. So root 2 and here root 3. So orders are same. Now here 2 is there, here 3 is there. Which one is greater or which one is smaller? Square root of 2 is less than square root of 3, or else square root of 3 is greater than square root of 2. So this is that comparison. If you take that one more example, that is cube root of 5 and here cube root of 7. So which one is greater? Again we have to say that their orders are same or not. So here say that what is that order? Here 3 and here also order is 3. So orders are same, right? So here now we need to see that radicands. So what is that? First radicand, that is 5, and the second radicand is 7. So which one is greater? Here 7 is greater. So we can write this one as cube root of 5 is less than cube root of 7. Or else cube root of 7 is greater than cube root of 5. So this is the way of comparison. When we are having that same orders, then only we can compare like this by using their radicands. Now if that orders are different, then how to compare that surds? We will say that. Next one is, if the orders are different, then how to compare? Here we need to follow some steps. We have to follow these steps. So what are the steps? So first one is, we need to write that orders of that given surds. So first we need to write orders of the surds. That is the first one. Next we need to take that LCM of their orders. LCM of orders. Next we need to take that multiply and divide each exponent by their LCM. So last one is compare the surds. So if the orders are different, then we have to follow that these 4 steps to find that which one is greater and which one is smaller. So first say that what is that First rule, that is orders of the surds. First we need to write that orders of the given surds. Next we need to take that their LCM of the surds. LCM of that order of the surds. Next come to the third one. We need to multiply and divide each exponent by their LCM. After that we need to compare that surds. Okay, here one of that example, that is square root of 2 and cube root of 5. Square root of 2 and cube root of 5. Which one is greater and which one is smaller? We don't know that, right? So here order is 2 and here order is 3. So first we need to write that orders of the surds, right? First thing we need to write that orders. That is 2 and here the order is 3. Okay, that is the first point. Next come to that second point, that is we need to take that LCM. So LCM of 2 and 3 is, children, we know that 2 and 3 both also prime numbers. So how to take that LCM of a prime number? Here if the given numbers are prime numbers, then their LCM is their product. So here 2 and 3 are prime numbers. So here LCM is what? Here LCM is 2 into 3 is equals to 6. We need to take their product, right? So here 2, 3, 6. Next thing is exponents. So exponents, first how to write this one is exponent form. So root 2 is equals to, we can write it as 2 power 1 by 2. Okay, and here cube root of 5, which is equals to 5 power 1 by 3. Okay, so here exponents means 1 by 2 and 1 by 3. So here exponents 1 by 2, 1 by 3. So come to that third point. What is that? Multiply and divide each exponent by their LCM. So here each exponent, what is that first exponent? 1 by 2 into multiply and divide. So 6 by 6. So we will get this one as 2 1s and 2 3s. So here we will get it as 3 by 6. Okay, next 1 by 3. Again we need to multiply and divide with LCM, that is 3 1s and 3 2s. So here we are getting this one as 2 by 6. Now apply these exponents to that given surds. Okay, now here we need to write that given surds. What are those? Square root of 2. So we can write this one as 2 power 1 by 2, right? Now apply that exponent here. Then how we can write that? 2 power 3 by 6. We can write it as 2 cube whole power 1 by 6. Yes or no? So here 6th root of 2 cube. Okay. And the next thing, what is that radicand here? Next radicand is 5 power 1 by 3. Why? Because that is the cube root of 5. So we can write this one as 5 power 1 by 3. By applying this exponent, we need to write this one as 5 power 2 by 6. Okay, we have to apply that one. Why? Because here 2 by 6 is an equivalent exponent of 1 by 3. Or equivalent fraction of 1 by 3. After cancelling these two, again we will get it as 1 by 3. Here also same thing. After cancelling 3 by 6, again we will get it as 1 by 2. Okay. So apply here this one. So 5 square whole power 1 by 6. So again we can have to write this one as 6th root of 5 square. 6th root of 5 square. Here 6th root of 2 cube means 6th root of 2 cube. 2 2's 4, 4 2's 8. So 2 2's 4, 4 2's 8. And come to this one. This is 6th root of 5 5's 25. Okay. Now observe that surds. Here these two also having that same order. Here this is also having 6 and this is also having 6 as their orders. Now the orders are same, then we have to follow that the first thing. What is that? If the order is same, then we can compare that surds very easily based on their radicands. Okay, now observe here the radicands. Here the radicand is 8 and here the radicand is 25. So which one is greater? By observing these two, 25 is greater than 8 and here 8 is lesser than 25. So which symbol we have to write? 6th root of 8 is less than 6th root of 25. Okay, now apply that given surds. Actually given surds are what? Root 2 and cube root of 5. Actually these two are given surds, right? So here square root of 2 is less than cube root of 5. Is it clear? Or else we can write this one as cube root of 5 is greater than square root of 2. So children, by using this method we can compare that any two surds, two or more surds, if their orders are same, then easily we can compare that surds based on their radicands. If that orders are different, then we have to follow that 4 steps what we discussed previous. Those 4 steps we have to follow. Okay, first we have to write that orders of the surds. Next we need to take that LCM of that surds. After that we need to multiply and divide each exponent, okay, by their LCM. And finally we have to compare it. Okay, after converting those two given surds into that having a same order, okay, after converting like this with the same order, then we can compare that surds very easily. Is it easy or not? Yes. So children, next we need to discuss about that laws of radicals. So here we have that some rules. So how to follow that? I mean, we have that in generally we have that 4 fundamental operations, right? So how to use that 4 fundamental operations in that surds? Okay, we will see here. So first one is a into nth root of x plus b into nth root of x plus c into nth root of x. Okay, just observe that here this is nth root of x, nth root of x, nth root of x. So by seeing only we can say that these all surds are similar surds. Why? Because these all surds are having that same irrational part. Here nth root of x, nth root of x, and here also nth root of x. So these 3 surds are similar surds. And here which fundamental operation we are using? That is addition. So we can add that only similar surds. Okay. So a plus b plus c. So which part is in common? First I am writing that common part. So nth root of x I am going to take that one as common. Now leftover part we have to write. So here this is a plus b plus c. So what is that first law? While adding that given surds, if that surds is in the form of a into nth root of x plus b into nth root of x plus c into nth root of x is equals to nth root of x into a plus b plus c. Okay, this is the first law based on that addition of surds. Just one example. 2 square root of 3 plus 5 square root of 3 plus 4 square root of 3. Okay, just observe that here we have to say that same irrational part as well as their orders also same. Okay, so here square root of 3 and square root of 3. Same irrational part and same surd. Now we have to take that same irrational part as common. Okay. The common thing first we have to write. Now we need to write that rational parts. So that is 2 plus 5 plus 4. So how much we will get? Root 3 into 2 plus 5 that is 7 and 7 plus 4 that is 11. So finally we will get it as 11 root 3. Is it clear, children? So here if that given surds are similar surds, then only we can add that surds. So this is that first law. Come to that second one.